All right, my friends. A claim was put forth when we were doing Monty Hall. And I think it was Kate, I'm not sure. Maybe it was Echo. It was Echo, actually. The claim was, when you pick the first door in that 3-door puzzle, you're only going to get the right door on your first pick 1 in 3 times. 1/3 of the time. I want to make sure, after you leave here today, you understand what that fraction means. And I don't just mean 1/3, but the idea of a probability fraction. So what I want to talk about today, and we're going to collect some data to do this, is an introduction to probability. You're going to notice a distinct change from the way class was, even last class, very highly algebra-based, to a straightforward kind of relativistic thinking that is probability. So I want to start by asking a simple question. I've just given you all a penny. What is the chance? What is the chance of flipping heads on a penny, or any other coin for that matter, or other coin? Assuming that I'm envisioning coins that all kind of look the same. They've got a head side and a tail side. So, friends, go ahead, be brave. It's the same 50-50 that Kate and Amy mentioned before, and I want to refer back to what you guys said before because it was totally awesome, and I want to make sure we compare and contrast it with the Monty Hall question as we go. So, right away, first of all, you're going to get tired of writing this really quickly. So I want to introduce some notation that'll make life easier for us. When we say what is the chance, we could just use the big letter P for probability, and then put in parentheses what we're talking about the probability of. So probability of flipping heads on a coin. Flipping heads on a coin. I heard 50-50. 50-50 actually defines not probability, but what's called odds. That's the odds in favor of getting heads. 50-50 reduces to 1-to-1, which means you're just as likely to get heads as you are not to get heads. So rather than 50-50, can I call it 50%? Is that okay? It says the same thing, but in a different way. We could say 50%. You could also say it as a fraction, as 1/2. You could also say it as a decimal, 0.5. You could say it in many different ways. You could change the decimal to 0.50. You could change the fraction to 10/20ths. However you want to do it. What you're looking at, I'm going to refer to the fractional part of this one here. This 1/2. Why the 1 and why the 2? Why the 1 and why the 2?
We started with 2.
There's 2 what?
2 head.
Good. So what I'm going to do, thank you, Timothy, I'm going to extend this out a little bit. I'm going to be more general. 1 and 2 is specific to flipping a coin and some other events. But in general, the number on the bottom, the size of this number talks about the number of possibilities or possible outcomes in an experiment. This is getting longer than I thought it was. It's a hell of a fraction. That's the number of possible outcomes in an experiment. Slide that over this way. There. So if you flip a coin, there are 2 outcomes. You get heads, you get tails. There's one thing that's hidden in there, and I mentioned this, Amy, when you said the 1 and 2, and Kate, when she reiterated the 1 and 2 with Monty. These possible outcomes that are down here make a big assumption. These outcomes are what is called equally likely. What that means, you're just as likely to get heads as you are to get tails. There's a difference between that and what happened in Monty Hall. Because when you switched doors in Monty Hall, it was dependent on whether or not you got the correct door in the first place. If you got the correct door in the first place, you shouldn't switch. If you didn't, you should switch. But they're not equally likely. because there was a 1 in 3 chance that you got the correct order, and a 2 in 3 chance that you didn't get the correct order. That's the difference between, that's why you can't use 0.5 and Monty Hall. They're not equally likely. But for flipping a coin, there's no reason to think it's not. The number 1 up top, let's talk about that. What's this number up here, this 1 out of 2? What's the 1 part? So 2 is the number of possible outcomes. What's the 1? Good! The number of ways that you get the outcome you're interested in, right? It's the number of ways you get the outcome that you're interested in. Number of, let's put desired outcomes. I'll put that in quotes because, I mean, it's a word like that. You're interested in flipping heads, so that's the number of ways to get heads. So the number of desired outcomes for the experiment. Sure. Now, again, very wordy, so I'm going to throw a couple terms at you now, and we'll use this over and over again today and also on Thursday. This top number is called the event space. And the reason it's called an event space is because the word that's usually used in probability classes, the desired outcome is called an event, and the bottom number is called the sample space. I don't know why, it just is. So what this is it's called the classic definition of probability. Actually counting everything that can happen, and then seeing how many things can happen, and forming the ratio of that divided into the number of desired outcomes. And that's fantastic. That is. It's super fantastic. Unfortunately, it's not how most mathematics is done in the world, because most mathematics doesn't revolve around flipping a coin. Although flipping a coin is a fantastic way of introducing this. What does the 1/2 mean? I mean, I know it means that there are 2 outcomes and one of them is desirable. But if you had to explain that to your neighbor who's never had a stat class before, or a prob class before, and you handed them a coin and said, go ahead, if you flip heads, you can have my lawnmower. But if you flip tails, I'm going to take your lawnmower. Would that person take the bet? Why? Depends on the lawnmower. Well, small plate, sir. Depends on the lawnmower. Right. So here's what I want. I want to help us answer that question. I've given you all a coin. I've given you all a penny. Here's what I want you to do. I want you to flip it. We got a bunch of us here today. Flip it 10 times and write down the result of each one of the flips in order. And then once you do that, we're going to add our, here we go. We're going to add all of our results to the board in one big long line. Okay? So everybody flip and get a sequence of 10 H's and T's. I'm going to go ahead and turn this off.